Hello, 56th grade. This is your science video for Wednesday, November 11th on Veterans Day. And just to let you know ahead of time, we are not doing page 75. It's not even for extra credit. And so you can just go ahead and put an X on that. And then we're going to look at page 76. Now, page 76 is a study guide. So these are things that you should already know. If at the bottom of it, you'll notice that it's from pages 105 to 108. And so we're going to look at that and read the pages that we need to read, which are 112 and 113. So let's look at that and read that together. I think I have the wrong page here. Hold on a second. No, not 112, 113. I'm looking at the wrong day. It's 100 to it's 105 to 108, just like it said on the bottom of that page, like I should have looked at myself. So 105 to 108 is talking about space. All right. Now these questions from this section might be on the test, but there won't be very many of them. And so, although you can use those, of course, for the test, and so you can understand that you don't need to really know where those are as much. There may be one or two about space, but most of them are going to be from the other parts of the test, or the books that we've read. All right, so heat in space. People have designed many kinds of technology to control heat. Sometimes the purpose is to make equipment run better. Other times it is to make people more comfortable. During space travel, though, controlling heat is not just a matter of efficiency or comfort, it is a matter of survival. The lives of the space crew depend on it. Space is a very cold place, but the sun's radiation causes objects in space to heat up. The Earth is protected by the atmosphere. Without the protective layer of the Earth's atmosphere, objects in space get very hot if not cooled in some way. As a spacecraft travels, it can move from the area of intense heat to areas of intense cold within seconds. Scientists and engineers must plan carefully to keep the spacecraft and everything inside it within a specific temperature range. Space capsules. At the beginning of the space program, rockets designed for manned space travel had a capsule at the top of the rocket. Only the space capsule with the astronauts inside returned to the Earth. This capsule had a slightly curved bottom. While entering the Earth's atmosphere on its return, the bottom of the capsule faced toward the Earth. This design slowed the capsule down. Although the design slowed the capsule down, the curved bottom also produced much friction. The heat from this friction caused the capsule to get very hot. The exterior could reach temperatures higher than 1,000 degrees Celsius. That's 1,832 degrees Fahrenheit as it dropped through the Earth's atmosphere. No one inside the capsule would have been able to live through it. So scientists and engineers, here I go again, yawning, okay? Scientists and engineers had to find a way to remove some of the heat. To solve the problem, scientists use an idea similar to how sweat cools your skin. They put a material on the capsule's outside that melted and vaporized as the capsule heated up. As the material vaporized, it cooled the capsule. Sweat keeps us cool in much the same way, so they're using one of those basic processes and laws that God made to be able to do this. All right, page number 106. Tiles in the bottom of space shuttle. As scientists and engineers developed a new spacecraft, new problems had to be solved. The cooling method used on a space capsule would not work on a space shuttle. Space shuttles were meant to be used again. They could not use material that would melt and vaporize. A space shuttle was also larger than a space capsule. More size means more surface area to cause friction. It also means that more surface area gets hot. As a shuttle returned to the Earth, the shuttle's exterior could reach 1,650 degrees Celsius or 3,000 degrees Fahrenheit. This would cause the shuttle's aluminum frame to melt if not protected. To protect the shuttle and its crew, several kinds of insulation were used. One kind is like a heavy blanket. It was made with waterproof glass cloth and was quilted. This kind of insulation protected areas of the shuttle that do not get the hottest. A shuttle also used ceramic tiles as insulation. A shuttle returning to the Earth glided like an airplane. In doing this, the bottom of the space shuttle produced most of the friction that slows the shuttle down. However, the friction also caused the bottom of the shuttle to heat up more than any other part of the shuttle did. For this reason, special tiles designed to protect against very high temperatures covered the bottom of the shuttle. Faulty tiles can create serious problems. Scientists believe that tile damage caused the breakup of the Space Shuttle Columbia in 2003. The tiles may have been broken or damaged during liftoff. When the shuttle returned to the Earth, the tiles could not protect the shuttle from the intense heat. The shuttle broke apart, as it flew back into the Earth's atmosphere. The International Space Station. The International Space Station, or ISS, is a large spacecraft that is also a science lab and a space habitat. People from several countries have occupied it since 2000. The ISS orbits the Earth about every 90 minutes. When it is facing the sun, the temperature is about 121 degrees Celsius or 250 degrees Fahrenheit. However, when it's in Earth's shadow away from the sun, the temperature drops to 157 degrees Celsius, minus 157 degrees Celsius, or minus 250 degrees Fahrenheit. So the exact opposite direction. Similar to the shuttle, the ISS is insulated by a special blanket made of mylar and dacron. This blanket has layers that stay separated to keep heat from being conducted through the layers. And remember about conduction, air is a very poor conductor of heat. And so that's what they're talking about there. It says the insulation on the ISS keeps heat outside the station, but it also keeps heat inside. Computers and other electronic equipment generate a lot of heat as they work. Just imagine how much heat is produced by all the equipment astronauts use. The ISS also has a system similar to an air conditioning unit that cools the inside of the station. Pipes inside the station circulate water through devices that help absorb and remove the excess heat. However, it is so cold outside the station that the water would freeze quickly. So the heat is transferred to pipes filled with ammonia. The heated ammonia circulates through large radiators on the outside of the station. There the heat is released into space. The ammonia does not freeze because it circulates back inside the station before it loses enough heat to freeze. So obviously it can freeze, but it doesn't. Then on page 108, modern spacecraft. Radiators and heaters have often been used to control heat in space, but those are heavy and take up a lot of room on the spacecraft. New spacecraft and equipment are often lighter, smaller, and more efficient than previous ones. As we learn more, scientists and engineers make changes and add new technology. The space capsules and shuttles were manned missions. People traveled in those spacecraft. However, some spacecraft are robotic. An unmanned research spacecraft is called a probe. Probes that can land on a planet or other space objects and move around are called rovers. The rover Curiosity arrived on Mars in 2012. Scientists are using Curiosity to study Mars. Mars is colder than Earth, especially at night. The rover uses a combination of methods to control heat. Some parts of it are painted with a special gold paint that helps radiate heat outwards away from the rover's body. There is also a special layer of insulation called aerogel that traps heat inside the rover's body. Fluid-filled tubing allows unwanted heat to circulate through the rover's system and to be released out into space. Switches automatically turn heaters on or off to maintain electronics and battery temperature during night on Mars. Through the space program, we have learned many things about our universe. All our knowledge could not have been gained, however, if we were not able to control heat. We are affected by thermal energy in many ways every day. We dress in clothing that is appropriate for how warm or cool the day is, with the exception of Ella, who seems to be cold no matter what. We put ice cream in the freezer so that it will not melt. We use a wooden or plastic spoon instead of a metal one to stir boiling liquids. Each of these decisions is based on our knowledge of how thermal energy and heat affect us. Thermal energy is an amazing part of God's creation. It can be used as a powerful tool in many different areas. Everything from refrigerators to electricity requires understanding thermal energy. Byproducts of thermal energy can sometimes be dangerous. Protecting human life also means learning about thermal energy. A Christian can glorify God by studying how to use thermal energy. So your secret word today, for Ella and for her sake, it's going to be sweater. All right. Have a good day. We'll see you tomorrow. Bye.